Hello friends, in this video we are going to discuss about phase failure relays, which is a very common and a very important component of any industrial motor control circuit. So let us see what is the function of this phase failure relay and how it works. So before getting into the main objective of the phase failure relay, we must know what are the type of problems which could happen in a three-phase motors, in industrial motors. So there could be a problem with the phase sequence. There could be a problem with the phase loss and phase unbalance and sometimes voltage levels. So we need to have a device which can monitor the phase sequence, which can monitor the phase failure, and also which can check the phase unbalance, and also we need to see the voltage level of the three-phase supply. So let us understand what is phase sequence and what is the consequences of not having a proper phase sequence. Phase sequence in general, if you take a three-phase system, one phase to another phase, there is a 120-degree gap. So we have three phases. So 120, 120, 120. So 360 degrees will be covered. For example, between R phase and Y phase, there is 120-degree phase angle. And between Y phase to B phase, again 120 degree. And from B phase to R phase, again, there is 120 degree phase angle. To take a reference as the R phase, the R phase comes first, and then Y phase, and then B phase. So this is how the sequence. In case if you change this order, any two phases is get interchanged, then the motor running direction will change. That is how we change the direction of rotation of a three-phase motor. For example, we have RYB. Instead of having RYB, if I have RBY, what will happen? So the motor direction may change from the original direction of rotation. Sometimes we need them to get the required motion, forward and reverse motion. Sometimes it is not. Okay, so we must have a proper phase sequence to obtain the proper operation of that particular motor. So we need to monitor whether the phases are coming in a proper sequence. The second one is phase loss. We have a three-phase system. In any one of these phases, R, Y, B, if you say, for example, you have R phase and B phase, all of a sudden the Y phase is not available. It means the fuse may be blown, or the particular, the line conductor or something is damaged. Okay, so because of any one cause, so one phase is lost. Only we have two phases. The motor is already in a running condition. So now what will happen? Because of this two-phase availability, the motor still runs. The three-phase load which we are connected requires more current, which needs to be shared by these available two phases. Because of this, the current from these two available phases will increase, and due to that, high current, and because of that, high temperature in the coil as well as in the insulation, which may lead to insulation failure, and the insulation failure may lead to short circuit, and the motor finally get damaged. So we must address this phase loss problem immediately. And phase unbalance. The phase unbalance is nothing but each phase should have a particular constant voltage. Say, for example, R phase with respect to neutral as 240 volt, Y phase with respect to neutral as 240 volt, and the B phase also should have 240 with respect to neutral. In case if it is not there, the B phase is having only 180 with respect to neutral. So this condition is called as phase unbalance. So any one phase or two phase has more or lesser value than the other phase. So this condition is called as phase unbalance. So this, because of this, there could be a more stress on the coils, and it could lead to further problems. Then the last one is a voltage monitoring purpose. So we must monitor the voltage levels of all the three phases It should not go beyond the limit. Also, it should not go lesser the limit as well. So we should have upper threshold and lower threshold, and the motor should run within this voltage limit. In case the power given to the motor is not in that limit, so then it has to isolate the motor from the supply. So these are the functions of phase failure relay. So with these objectives, we are going to phase failure relay. So this is what I was explaining about phase unbalance. You see here, we have a three phase. In that, any one phase is having lower value of voltage. You see this phase and this phase has maximum value, and the third one is having a lower value. So this means the voltage level in the third phase is lower than the other two phases. This is phase unbalance. And phase loss, we have only two phase. The third phase is lost. So there is no availability of the third phase. So in this condition, the motor runs with only two phases, which may overload the coils and the insulation. And voltage monitoring purpose, here we have three phase. The normal voltage requirement is shown in the darker part, and in sometimes it may go higher limit or it can go lesser than this required value also. So when we go higher voltage or under voltage, we must get notified or we have to take a proper action. So this is also a purpose of having the phase failure relay. Okay, so there is one simple clarification for this voltage unbalance. So let us take the voltage in phase AB, or you can say between line A and B, 496. This is only for example, 496. And between B and C, we have 460 volt, and between A and C, we have 470 volt. You see the voltages are different. Okay, so it should be, ideally speaking, it should be equal, but we have a different voltages. So we must know what is the percentage voltage we have as an imbalance. Okay, so let us, how to calculate that? So let us take an average of it first. 496, 460, 472 divided by 3. So the average voltage is 476. So now let us take the bigger value or the highest voltage value, subtract it with the average value. So you get a difference. Okay, so we have a difference of 20 volt. So now the percentage difference is this one, the voltage, difference voltage divided by the average value. So you get 4.2 voltage. So this is the voltage unbalance in this particular example. So because of this voltage unbalance, how much heat is produced in the motor? How to calculate them? So it is 2 times of the percentage voltage unbalance square. Okay. So here 4.2 is the percentage. 2 times of voltage unbalanced square, we get 35.28 percentage as an increase in the winding temperature with the highest current. So you see only 4.2 voltage difference is there, but it leads to 35.28 percentage temperature increase in the winding. So if the voltage difference is more, then the temperature increase also will be more. If the temperature increase is more, obviously the coil damage or the insulation damage will be definitely going to happen, or it is going to be certain. So we must act upon this condition. So sometimes the overload relay may not recognize this problem fast. So that's why we are having this phase failure relays. So how to get this phase failure relay function with the normal relays? So for a three-phase system, only if you want to see whether the phase loss condition, we can go for this circuit, what I have here. I have a power circuit. Also, I have a control circuit here. So I am going to use two extra relays for achieving this phase failure concept or the phase loss concept. So here I'm not going to see the phase sequence, or I'm not going to see the voltage imbalance. Only I'm going to see the phase loss. Okay, so let us take how this circuit works. Let us see. See from here, let us take from here, our phase is coming through the MCB control relay or control MCB. and from the control MCB, it is going to the contact of the second relay. Okay, so the current, the R phase current or the control current is passing through this switch, and it is also passing through the second switch, and it is going to the control circuit. Now, if the R phase is not available, if the R phase is not available, then the current will not flow any, even though the switches are closed. So this is first condition. If R phase itself not available, even if the relay contacts are closed, then obviously the power flow will not take place. Then R phase is available. In case if Y phase is not available, what happens? This contactor will open this switch. So the current will stop here itself. The power flow will stop here itself. Okay, so now R phase and Y phase also available. So that means the power will be available until this point. And if B phase is not available, so this relay will open. So that the power flow will stop here itself. Okay, if all the three phases available, then only the control circuit will get power to the control contactor here. Okay, so the power will be available. So when you press the push button, then it goes to the contactor coil, and the contactor coil is getting energized. So this on push button is getting latched through this latching concept. So it is continuously monitored. In any one of the phase not available, so immediately the control circuit will disconnect the power. So when the control circuit doesn't have the power, then automatically the contactor will open the circuit. So this particular circuit is going to protect the three-phase motor with a phase loss condition only. It is not going to see the phase voltage levels, or it is not going to see the imbalance in the voltage or phase sequences, or it is not going to monitor the temperature of the coil of the motor. So there are now devices, ready-made devices, which is available to do this function. So where I have multiple options, the balanced voltage or unbalanced voltage conditions, or the phase sequence, the proper phase sequences, and also it is going to monitor the temperature of the coil. If any one of these conditions not exist, then automatically it is going to trip the circuit. So if you see this circuit, we have the power coming from the L1, and it goes to the start push button and then the stop push button, and we have a T1 switch for the temperature operated overload relay NC switch, and then it reaches to the input side of the phase failure relay. And also we can see here the three-phase lines and the neutrals connection is given here. So these inputs will give the conditions. All the three lines are available, and all the three phases are having an equal voltage, and it is in a proper phase sequence. All these conditions, okay, will be checked here. Once these all conditions are satisfied, then the power which is coming in the second terminal will be transferred to the third terminal. So when it is going in the third terminal, it will reach to the contactor coil. So when the contactor coil is getting energized, then the contactor will get closed here. So when the contactor is closed, then the motor will run. So in case of any overload or the phase failure or some reason, if the coil temperature rises to certain point, so this feedback also is given back to this phase failure relay. In case if the temperature reaches to certain extent point, then automatically it is going to disconnect. So this is how the phase failure relay connection looks like, and it is how it is going to function. So that is for only one direction, like the motor is going to run always in a forward or reverse direction, only one direction. In case if your motor is going to have both the direction of running, forward and reverse, so we may have the connection like this with the reversing starter. So only difference is that we connect this device just before we take out all these forward and reverse contactors. So this forward and reverse contactor, as usual for the any forward and reverse control of an induction motor, how we do, that is how we did this one, because here interchanging of any two phases for changing the direction of motor is achieved through the reverse contactor, and the forward contactor directly connects the motor with the supply. So the forward contactor will make the motor in one direction. The reverse contactor is going to make the motor to run in a reverse direction. And in case of a voltage imbalance or phase sequence, okay, so our voltage variations, then what is going to happen? So this particular device is going to give a signal and it is going to turn off the device, turn off the contactors in the main control circuit. See here, this device contact is here. Okay, in case of any phase failure problems like phase loss or phase sequence problem or voltage imbalance or any problem because of this temperature problem or any one of the problem, if it is identified by this device, then immediately it is going to open this contact. If all this condition is okay, then only the power will transfer to the control circuit itself. If the control circuit is not getting power, then the power circuit is not going to operate at all. So first you need to satisfy all the condition, then it will give the signal for the control circuit. Then when you are operating forward or reverse, accordingly the motor is going to run in forward and reverse direction. Thank you. Hope it is clear. And if you have any doubts, please let me know.